Hi guys, today I'm going to show you how to use open source AI models to remove noise from high ISO images. Now, you may have seen advertisements for something like Topaz AI or Lightroom and their ability to remove noise from high ISO images that you shot on your camera. Say you shot it at maybe 20,000 ISO or maybe 6400 ISO or some high value like that. And when you pull the image up on a screen, you can see all the noise on the image. Well, with an app like Lightroom or Topaz AI, you can just simply load the image up into that app and then use a slider to kind of adjust how much noise you want to remove. And then it will do a pretty decent job of taking all that noise out and making the image look really natural without all that noise. Well, you can get kind of similar results to that if you use some open source software. So I'm going to show you some of the models that you can use to get results like that. Now, I'm not going to claim these are as good as Lightroom or Topaz AI, but I just want to show you the results and what you can kind of do if you don't want to pay for these applications and you have a little bit of patience. You can use open source and get some pretty decent results in any case. So let's just dive right in and look at my original image. I'm going to show you the results from using something that's more algorithmic like Gimp or Paint.net. Then I'm going to show you some results from Lightroom and Topaz. And then I'm going to use some AI to show you how you can denoise images and then compare and contrast that to something like Topaz or Lightroom. So here are some of the outputs from what I've been working with. And a few of these used AI. I use Gimp just kind of as a baseline so you can see what just an algorithmic approach to denoising would do. And then I have some outputs from Lightroom as well as Topaz here. But let's take a look at the original. But before we do that, let's take a look at the EXIF data on this image. So I took this at ISO 20,000. So it's a fairly high ISO. I wanted to do this video, so I just went outside and I found an image that I thought would be a good candidate, one that's got some areas of pretty homogeneous color and other areas that are pretty detailed, and this one kind of fit the bill. So I did a macro of a lily, and so these Steinman right here has some detail on it, but it's against the petal is pretty homogeneous in its color. So we have some contrast on the details, but we have some areas of homogeneous color as well. So this one should be a good one to work with. So I took this one with a macro lens and then got this resulting image right here. And if I open this guy up, you can see just by looking at it on this photo viewer here that the noise is already showing up. I haven't even zoomed in yet. But if I zoom in kind of in the middle of here, you can definitely see the noise now. You can see these areas of homogeneous color over here on the yellow is just full of noise. That's because it's a high ISO image, but you see noise in the details too. Noise in the details can be a good thing depending on the image. It really preserves a lot of the details of that texture that we see right here, but over here we don't want that noise because that's really not a textured area. So we're gonna have to kind of choose where we want to focus on this. If do we want to remove all the noise from this more homogeneous field, or we want to preserve some of the noise to preserve some of the texture in this part of the image as well. So that's kind of why I chose this image. So let's look at some of the results of this first, using some of the algorithmic approaches like what you would get with Gimp. So I opened up the image inside of Gimp, and if we zoom in on this, we can see that it's that noisy image that we had before. And this is, again, not the prettiest image in the world because of all that noise, but I can at least try to remove some noise with it using the filters here. So if I go to Enhance and I go to Noise Reduction, I can just use the built-in noise reduction right here and attempt to remove noise using this. This is basically the strength of it, and it gives you the ability to set the opacity. So basically the blending mode is how much or how little of the denoised layer do you want to have versus the original. And so that's kind of what that's giving you. So if you want to preserve detail, but it's going to also preserve noise, you can set the opacity to lower, but if you don't want any of that represented, you just want the denoised image, you can set it to 100 and then click go, and it's going to denoise the image the best it can using an algorithmic approach. Now, the compromise you get with this approach is that sometimes you lose some of the clarity of the image. So it's not nearly as sharp as it might have been otherwise, but you can at least somewhat get rid of the noise. So if I zoom back out, it's not as apparent as the noise, although you can kind of still see quite a bit of the noise in this image, even though I took an algorithmic approach. And that's just because this is a really noisy image. So let's look at some of the other approaches using AI versus something like just using an algorithmic approach, what's built into Gimp. So let's take a look at Lightroom and Topaz as a point of reference. Now, I'm not going to show you how to use those. Those are pretty straightforward and you can probably figure out how to use them. I'll show you how to use some of these other open source models in a minute. But as a point of reference, I'm going to show you Lightroom and Topaz because I think these are kind of the benchmark for what you can expect from noise removal software. Now, this is the output from Lightroom, and you can see that I left a little bit of the noise in here, and that's because I like to have a little bit of texture in any case, so it doesn't look as flat. And this did a pretty decent job of removing the noise in this part of the image while still preserving a lot of the details. Now, of course, it's not going to look nearly as good as if I would have shot this at like ISO 100 or 200 because just inherent to noise removal is removing detail as well. But I think there's enough there that if I was to work with Lightroom, I could probably pull out the texture, improve the clarity, and do those kinds of tricks with it. And it would kind of bring a lot of that back. And I could get something that was pretty close to what it looked like if it was of a natural photo without a high ISO setting. In any case, this is what the Lightroom does. And I think it does a fairly good job. And it's honestly, in my opinion, one of the best ones out there. If I look at what Topaz produces, I'm not as excited about Topaz and what it does to denoise. From this view, it looks really detailed, but if you zoom in, I think it kind of destroys a lot of the detail right here. It does a decent job of removing noise from some of these homogeneous fields right here. I didn't completely remove the noise to leave a little bit of texture in it, but it left a lot of noise in right here while not bringing out a lot of the detail at the same time. So this one, in my opinion, is a little bit subpar from what I would expect. Although sometimes Topaz can do a great job where Lightroom struggles. So just depends on what you're shooting. But this one was a fairly challenging image. What Topaz attempts to do, and I think it's just the way that it attempts to remove noise, is where it sees a lot of detail right here, it attempts to leave noise in while seeing a big homogeneous area right here, attempts to remove more of that noise, because in leaving noise in, as I mentioned earlier, it preserves a lot of the detail. But in a really noisy image, that can actually be detrimental, while Lightroom removed the noise from both sections. And you can see that I think the output from this section was a lot cleaner with Lightroom. Now, again, just depends on the image, but both do produce pretty decent results in any case. So you'll just have to figure out which one works best for whatever you're shooting and decide with that. But with this as a benchmark between Lightroom and Topaz, I want to look at some of these open source models to see what we can expect from them. So I had 3 models to test with, and I chose 3 different models for different reasons. One of them is just a strictly noise removal model, which is called Noise Toner. And I chose 2 upscaler models. And upscaler models aren't typically used for removing noise, but they can be, because part of upscaling images requires that you remove noise from the images so you don't end up with a bunch of artifacts in the upscaled image. And different models do that at different levels. So we can look at 2 different options there. Now this model right here doesn't do upscaling. It's just designed specifically for noise removal. And because I had a really noisy image, it didn't do the best job of removing noise. There's still quite a bit of noise in this image, even though I ran it through this noise removal model. And if I was to run it a few more times, I might get more noise out of it, but I think there's a point of diminishing returns on this one because it simply does not have the capacity to remove the noise like I would hope it would, because I guess it's just a really noisy image. And I don't want to fault the model. I just was using a very noisy image to test with. And I got really pretty good results out of Lightroom and okay results out of Topaz. But this one, I just don't think it did a really good job in any case. And so this is just not one that I would probably use, maybe if it was a little bit noisy, but as a result, I'm not really impressed with this one. However, these 2 models, being that they're super resolution models, do decent results. So let's take a look at this one. Now, this is the image after I resized it back down to the original size, and so that we would be comparing apples to apples. And so this one did a pretty good job of removing noise and preserving detail. So this looks a little better. It's not nearly as smooth as what you would get out of something like Topaz or Lightroom. But in any case, it did preserve a lot of the detail, which I kind of appreciated about this one, while still able to remove a lot of the noise and the artifacts were left over from that. So this one is definitely more oriented towards preserving detail, but also getting rid of noise at the same time. Now, if you want to completely remove noise like we saw with something like Lightroom or Topaz, the real ESR GAN would be that one right here. And this one did a pretty decent job of removing the noise, but I think it just utterly obliterated the details of this image. So there's just really nothing left on this. And this just doesn't have any life left in it. So I'd have a hard time bringing this image back to life. Having said that, though, I do want to talk about what you can do with this. If you do have the instance where you're removing a lot of noise like you would get with this one, you can actually just blend it with the original and kind of get a balance between a completely denoised image and also something that has a lot of noise in it. So let's just take a look at how you can use that as an approach if you want to like completely remove the noise and get something like this, and then just kind of merge it with the original to kind of get a balanced approach where you can adjust the opacity or something like that. So if you want to blend these images, it's pretty straightforward. Just open up Gimp. And then with Gimp, you can bring in the original image. I'm going to bring Gimp over here on this screen. Just bring in the original image as your base layer and import that one. Then bring in the denoised image layer, and that'll come up on top. And so if you have those layered like this, if I just hide the top layer, you can see that I have all the noise, and then I have the bottom top layer. When it's visible, it's fairly denoised here without the detail. So if I want to blend these two, I just take the opacity slider and just kind of move that around a little bit and get it to where I kind of like it. And, you know, I'm looking for a balance between noise and detail. So noise and detail in this case would be probably something about like that. I'm getting some of the details from the underlying image, but not reintroducing all that noise like that. So about 60 to 65% opacity is probably the sweet spot for this image. Now, of course, that's going to look different for different images. And if I zoom back out, I'm getting a fairly decent image that doesn't look obviously noisy. So something that's fairly decent there. So I can merge this down and just create a single image out of that, and then I can maybe apply a filter. Let's see if I have a enhancement here. Let's do a sharpening on this. That's just using an unsharp mask, which is a very traditional way of doing image sharpening. And so the radius basically is the amount of each pixel looks out for the details, for fine edges and that kind of thing, and then boost it up, and then the amount is just gonna like how drastic do I want it. Too much though, it reintroduces a lot of noise, but too much, not enough. It depends on what you're trying to do. So maybe a little bit of sharpening here. I'm still gonna have a little bit of noise in it just by virtue of that, but maybe I could apply a little bit of sharpening to it, bring a little bit more of that detail, and I get some pretty decent results with that. So let's export this guy, and let's take a look at it next to what we got with something like Lightroom and Topaz, just so that we can kind of compare the blended image between the original plus a denoise layer and what we might expect with something like Lightroom. So this is my blended image right here. And so if I zoom in here, still got some noise in it, and that's because I did some sharpening on it, and I chose to preserve some of the noise by choosing about 60% opacity, but not nearly as noisy as the original. And this is what we got with Lightroom. I still think this is probably a better result right here. I still have the details in this part, but I have a fairly noiseless region right here for that homogeneous region. And then similar with Topaz, I think I have a noiseless section right here, but a fairly detailed section right here. So that's what I'm working with. Now, what I did with these two premium applications is just work with what I had available in that. I could probably work with what I had in Gimp if I wanted to do some selective editing and then set the opacity for selective editing and get a fairly noiseless region right here while still having details in this section right here. But that's a lot of manual work. I didn't have to do a lot of manual work with this particular image using these premium applications because it was algorithmically able to detect where I have detail and where I don't. So that's the trade-off with using some of these open source software like I'm using here. In any case, now that we've seen the results from these models, let's look at how you can actually apply these models using a program called Chainer, which is a very nice program for building workflows for removing noise or upscaling or doing different things like that with AI models. So to apply the model, the image processor that I'm going to use is called Chainer. And this is a really nice tool for working with a lot of things image related. So you can use it for batch processing like upscaling, downscaling, converting, whatever. But it's also useful for applying models to images as well. So download this and install it on your particular platform. It's open source, so it's free software. You don't have to pay for it. And once it's installed, just launch it. And you can launch it, and it takes a few seconds to load, depending on the speed of your machine and the speed of your drive. It's got to load up a bunch of stuff. But once you load it, this is what the UI looks like. And this is just basically a workflow builder. Now, it's not intuitive what to do when you open this up, but I'll explain what that is in a minute. But before you can get the models to work with this, there's a few tweaks you have to do to the program, and that's basically to enable Python right here. So under Python, if you don't have it installed, it'll give you an option to install it. And it will basically just install it right alongside of Chainer. If you have Python installed on your machine, you can attempt to use that, although it could be conflicting with Chainer if it's a different version or you have different dependencies that aren't consistent. I would recommend just using the built-in Python that will install alongside the app, and you won't have any conflicts with other versions of Python that you might have installed on your system. So install that and then go to PyTorch. Make sure this is set to GPU. If you don't have a GPU, you can use your CPU mode. CPU mode's really slow, but if you have a lot of patience, it will work. And that's true of any thing that's AI related. But if you have a GPU, definitely use the GPU for this. I have an RTX 3060 Ti, which is not a high-end graphics card, but it's not a piece of junk either. So it works for this. So if you have something that's an older card or a newer card, it'll work just fine. And once you have this set up, restart Chainer, and then it will light up some options in the UI that weren't there before when you installed it. And that's all this stuff down here under PyTorch. So once you have all the stuff for Python set up, now we can build the workflow. The workflow is pretty easy to build. So we're going to drag this little widget right here onto the screen. It's just all drag and drop. We're going to load a model and we're going to load an image. So our image is going to be that original image. And so you can just choose the image. And if I choose original right here, it's going to load that and give me a preview. And then the model is going to load a model. On this one, I'm going to choose that real ASR GAN 4X Plus. And that one did a pretty decent job of removing noise. And so I'm going to use it. Now, this is an upscaler model, so it can be used to create super resolution images as well, but I'm not using it for that. I'm using it for denoising in this context here. So once I have these set up, I can then select another one down here under the Python options under PyTorch. I can use upscale image. Don't let this name confuse you though. Basically, this is for invoking a model. It can be used with any of the models that are used for image processing. So the model that I have here that doesn't do upscaling, noise, tone, or uniform, does not actually upscale the image. It just leaves it at the original resolution. And so even though that says upscale image, it doesn't necessarily have to upscale the image. But in any case, because I'm using an upscale model, I'm going to get an upscaled image here. So to offset that, I need to basically resize the image to its original size. So let's connect these together. So I can just drag and drop these nodes to upscale the image. So I have my image loaded, I have my model loaded, upscale is ready to go. And now because I am using an upscaler, I can then resize this back down to the original size by just setting this down to 25%. Because this is a 4x upscaler, if I reduce it by 1/4, it'll bring it back down to the original size. Now, the interpolation mode, I'm just going to set it to Mitchell. You can also use this one right here, Lanczos, which is a fairly good resizing algorithm, and that will bring it back down to the original size. And then once I have the workflow built like this, I can then save it. And so I can then drag the save widget over here and then connect the output from resize to save. And I can choose a directory, and I can put this back in the same directory as my other images. And then I can choose the output to TIFF and the image name as original Denoise or something like that for running this. And that's my workflow. It's fairly easy to build. Once you're done building it, you click the play button and it will run the denoise and upscale, resize it down the original, and then save it to disk. Now, depending on the speed of your GPU or your CPU, the size of the image, and a lot of other factors, depends on how long this will take. It can take no time at all. It can take a long time. Just be patient for your particular image and your particular platform. But once you get everything working, it's pretty straightforward and you'll be good to go. So this is the workflow. So once you have it built, you can just save it. So I'm going to save mine out on my downloads folder where I put my models. So it'll be right there next to my models. And I think I probably already saved it, Denoise chain, and save it. I'm going to overwrite it because it's the exact same thing. I just showed you how to build it. And run this and you will get an image output. You can just let it run. And once it's done, you will see the output image in your output folder. So I hope this has been an informative video. It's certainly been one of the learning experiences for me for learning how to do denoising using open source software and using some of these open source models as well. So with this one, you saw how we can create a output image that basically has no noise, and then using open source software like Gimp, you can blend it with the original to get something that's a balance between the details of the original image and some of the output denoised layers from the models that we were applying as well. And that gives you some results that are pretty similar to what we can get from things like Topaz AI or Lightroom. Now, I'm not going to pitch this as an alternative to Lightroom or Topaz AI because this is kind of a amalgamation of different tools. It's not like a unified workflow like we typically get with those tools, but in any case, you can get some similar results if you're willing to work with the tools that are available. But this one is zero cost to you, so you can definitely work with it and use it for your images. So if you like this content, please like the video, share it with your friends. Also subscribe to the channel. If you have other ways of doing this, I'd love to know about it. AI noise removal is something that I'm definitely interested in. Drop me a comment in the comment section down below, or you can ping me or just link to some stuff. I'd love to know about those approaches. And also, as always, thanks for watching.
If you like this content, please consider subscribing to the channel by clicking on the subscribe button. You can also like this content by clicking on the thumbs up or share this content with your friends, and also comment in the comment section down below. You can also find me online at www.blaze.net or on Twitter at @TheOneMule. And as always, thanks for watching.